Navigating the challenges of unstable soil, the construction of the Markthal in Rotterdam reflects the commitment to modern architectural innovation. After laying 480 tons of reinforcement, a 1.5-meter thick underwater concrete floor was poured and allowed to harden. Once the concrete set, the water was carefully pumped out, employing impermeable barriers and dewatering solutions to reveal a smooth, watertight floor capable of supporting up to 12,000 kilograms per square meter. With the foundation laid, the project moved upward to construct the unique horseshoe structure using the tunnel formwork system. Building the arch roof was a notable engineering endeavor, supported by temporary, mobile shuttering to accommodate the apartments and penthouses. Inside, the market hall features the Horn of Plenty artistic ceiling that spans 11,000 square meters, adding vibrant artwork to the space. The Markthal seamlessly blends market and residences, with single-glazed cable net glass facades enhancing transparency and connection to the city. Having tackled the foundational hurdles this week, we now move forward to explore the architectural feats involved in crafting the arch and keystone. The concrete arch structure formed the core of the Markthal, housing the market hall and supporting 228 apartments. Designed by MVRDV, the reinforced concrete arch spans 100 meters in length, 70 meters in width, and rises 40 meters high with a distinctive horseshoe-shaped profile. It not only serves as the roof of the market hall, but also as the structural base for residential and commercial spaces built atop and within its volume, efficiently distributing loads across its span. To construct the apartment wings within this complex geometry, tunnel formwork played a crucial role. Known for its speed, labor efficiency, and high-quality finishes, this system was ideally suited for the repetitive modular design of the housing units. Tunnel formwork is a 50-years-old technique. It is basically an operation to cast walls and slabs in one operation in a daily cycle. It is adopted to have a monolithic structure. This technique is highly systematic, earthquake-proven, and provides an ideal solution to the critical problem of sound transmission. Tunnel forms are inverted, L-shaped steel structures which are bolted together. This whole formwork can be moved to a specific place and height with the help of cranes. The technique gives a 24 hours construction cycle. Working cycle of tunnel form system is mainly divided into 3 parts. Specifically, during deshuttering, formwork panels are cleaned, oiled, and prepared for reuse. Wall reinforcement is positioned, beams fitted, slab reinforcement mesh, and electrical plumbing conduits integrated, followed by casting walls, slabs, and kickers in a continuous pour. Once set, the formwork panels are efficiently moved to the next site using a tower crane. Second to the 10th floors, using tunnel formwork. This created the structural framework for the sides of the arch, providing stability for subsequent stages. J.P. van Eesteren utilized tunnel formwork for the construction of the 2 vertical legs of the Markthal. This choice was particularly suited for the repetitive nature of the residential units along each side of the arch. Unlike conventional methods where walls and slabs are cast separately, tunnel formwork allowed them to be poured together in a single, continuous operation for the Markthal's residential units from the 2nd to the 10th floor. The construction progressed floor by floor, each composed of 15 cells per side of the arch. A set of 12 tunnel forms were positioned and aligned simultaneously, enhancing efficiency. 3 cells on each side of the arch. The use of these tunnel forms enabled the casting of 12 cells per floor within a streamlined 24-hour cycle. Steel reinforcement bars were placed to ensure structural continuity throughout the building. Embedded services such as plumbing, electrical conduits, and ventilation ducts were incorporated before the concrete pour. Concrete for both walls and slabs was poured simultaneously for a monolithic structure. Once the concrete achieved sufficient curing, the forms were detached and prepared for the next cycle, which was then repeated for the subsequent 12 cells. The construction team maintained an efficient pace, allowing an entire floor to be finished in just 3 days. Afterward, the tunnel form units were hoisted to the next level using cranes, allowing the project to adhere to a tight timeline without compromising quality, ultimately speeding up the building process. The tunnel formwork system was traditionally used for linear, vertical building typologies, but during the construction of the Markthal, the tunnel formwork system was adapted to the Markthal's curved shape. At each ascending level, the angle of the apartment slabs was incrementally adjusted, allowing the 2 vertical legs to gradually curve inward and ultimately meet in the central apex, gradually forming the arch. This engineering solution showcased the versatility of tunnel formwork and its ability to adapt to complex architectural forms while preserving structural integrity and construction efficiency. The arch was completed with the placement of a keystone element at the apex. This piece allowed the structure to transfer load effectively from the roof to the vertical legs or walls. Upon installation, the arch reached self-support, efficiently channeling loads down its curved surface to the supports and foundations without internal columns interrupting the space. The design allows loads from the roof and additional forces, like snow or wind, to transfer horizontally along the arch curve through compression, facilitated by each voussoir pushing against its neighbors, turning vertical pressures into horizontal compressive forces. At the springing points, the structure experiences horizontal thrust, naturally occurring as the curve tries to spread under load, while robust vertical supports absorb these thrusts to prevent lateral displacement. Once redistributed, the loads are directed down to the foundations, ensuring it bears the structure's final weight and safely dissipates forces into the ground, preventing uneven settlement. The keystone's placement locks segments into a stable, purely compressive configuration, allowing the arch to maintain expansive interior spaces without additional internal supports in its role as a public market hall. Consequently, the Markthal's arch exemplifies engineering principles, efficiently managing force from roof to foundation, ensuring structural integrity and an iconic architectural presence with a vast, open interior. The Rotterdam Markthal has a floor surface equivalent to that of a soccer field. The walls of the hall were constructed using normal building methods. However, the roof construction, including the penthouses, provided a particular challenge. The arch was constructed from 4 primary segments, each carefully placed to maximize stability and load distribution. The process began by building the 2 middle sections first, followed by the 2 outer sections. For each of the 4 roof sections, temporary supports were critical. 2 substantial temporary support towers were erected under the arch, providing stability to the sections during the construction and curing phases. This method ensured precise alignment and enhanced structural integrity, These temporary supports were moved as the roof sections were built, serving as mobile shuttering systems. Mobile shuttering systems are construction formwork that can be moved easily, reducing the need for frequent erection and dismantling. This temporary support had to function as a mobile formwork in the vertical direction. It also needed to be movable horizontally. CVL Technieken de Boer Spanlift designed and built this mobile shuttering construction. For the vertical direction, the temporary support had to bear a maximum load of approximately 3,000 tons. To manage vertical movement of up to 250 millimeters at 6 lifting points, Homatro provided 8 locknut cylinders, each capable of handling 680 tons with a 250 millimeter travel distance. These locknut cylinders were mounted under the posts of the shuttering construction. The control of the cylinders allowed the formwork to be raised precisely to the correct height to pour the concrete arch and position the concrete elements. After a few days, the entire support system, mounted on a proprietary sliding mechanism, was moved horizontally from the inside to the outside, shifting to its new position. This same system is also used for relocating tower cranes. 3,000-ton hydraulic skidding device, such as those deployed by CVL Technieken de Boer, is a high-capacity mechanical system designed to move extremely large and heavy constructions with exceptional precision using hydraulic power. CT de Boer's skidding systems are comprised of skid tracks, hydraulic push-pull cylinders, and Teflon or stainless steel sliding surfaces, all engineered to reduce friction and ensure smooth, controlled movement. The object to be relocated, like this massive formwork, is placed on skid shoes. Then hydraulic cylinders incrementally push or pull the structure along the track. These systems operate at pressures of up to 700 bar, 10,000 psi, using hydraulic pumps to control oil flow into cylinders, delivering the necessary force for each phase of movement. This cycle of action was repeated until the entire roof construction was completed. This week, we focused on the construction of the iconic arch, tunnel formwork system to mobile stuttering system, and completed with a central keystone. Next week, we'll explore the Markthal Energy Performance and Indoor Comfort. The building boasts innovative ventilation and underground heat storage for enhanced energy efficiency. Linked to the city's heating grid, its thermal storage system also heats and cools nearby buildings. The Markthal's design enables efficient heat and cold exchange across different zones, optimizing overall energy use. The main hall features a naturally ventilated system where air flows in through the glass facade, rises, and exits via ventilation shafts, creating a self-sustaining thermal environment. The Markthal stands as a testament to innovative, sustainable architecture, blending functionality with environmental consciousness.